let's talk about standard deviation. If you look at the formula here, it's much more complicated than the formula for mean absolute deviation, which is why it is not until high school that they do this calculation. So they're still taking the data point and subtracting the mean from it. But instead of taking the absolute value to make it positive, they square it to make it positive. In the population formula, they divide by n, or the number in the population. In the sample, they divide by n minus 1. In both of the formulas, they take the square root. So that is how the standard deviation formula differs than the mean absolute deviation. Let's look at it in terms of the housing conundrum. So remember scenario 1? Here's our housing prices. And you can tell that one is very low at $53,000 and the other is very high at $1 million. And then scenario 2, where our housing prices are closer together, where they range from $210,000 to $305,000. So we find the mean in both scenario 1 and scenario 2 to be $250,000. When we find the standard deviation in scenario 1, where the housing prices are very spread apart, we get a standard deviation of $371,470. That's rounded to the nearest dollar. And the interim work there is you take each one of the data values, subtract off the mean, square them, sum them, divide by 5, because that's n minus 1, and then take the square root. And that will give you that value of $371,470. So what does the standard deviation of $371,470 mean? Well, in this case, it's about housing prices. So it's saying the average spread of the housing prices is $371,470. We often report one standard deviation above and below the mean. Remember that the mean was $250,000. So one standard deviation below the mean doesn't make sense because we would get a negative value. One standard deviation above the mean would give us $621,470. So in this case, the mean was $250,000, so the prices ranged from 0 to $621,470 within one standard deviation. That's a very large spread. We may not realize that if we're only given the mean price of houses in the neighborhood. So what about scenario 2? Again, the mean was $250,000. If we go through the calculations, we find our standard deviation to be $41,971 rounded to the nearest dollar. So what does that standard deviation mean? Well, it's much smaller than the other standard deviation. So it's telling you the average spread of the housing prices is $41,971. And again, we often report one standard deviation above and below the mean. So in this case, our housing prices ranged from $208,029 to $291,971. This is much closer together than scenario 1. We might not realize that if we're given the mean price again. So interpret those. Remember that mean absolute deviation and standard deviation measure the same thing. They just measure them in using different formulas. So the smaller the standard deviation, the closer or more clustered around the mean the data is. The larger the standard deviation, the more spread out that data is from the mean. I hope that helps you understand standard deviation a little bit more. Thanks for watching.